system. So, hey everyone, it's Mick Lebinskas here from Climate Salad. I love sharing amazing technologies, and I've had the privilege recently, as a part of the UNSW Climate 10X program, to work with some incredible companies. One of them is Extraterrestrial Power, and I've got Peter here today, who is a co-founder, part of the team. Peter, can you tell us what ETP does?
Hey Mick, the extraterrestrial power is powering satellites and everything that the our future in space holds. Ultimately, we want to push down the price of electricity in space to below what it costs on Earth.
Wow. It's interesting. I remember reading about some of the first solar panels, the super expensive ones were used in space because obviously there are not many other energy sources up there. And nowadays, you don't really think about it that you've got to power these all these satellites up there. Just for the average person like me, I'm looking up at the sky, I can't see any satellites at all. And that's a daytime joke. But like roughly how many satellites are up in space? Just ballpark,
Currently, I think the number is around 10,000,
ten
and
thousand satellites.
and many of those satellites have bigger solar arrays than what you have on top of your house.
Wow. Wow. Well, I've got 10 kilowatts. So that's a lot. Um,
Yes.
but power in space is going to be growing, right? Like everyone's getting satellites up there. There's more and more. Like, what are the reasons why there's increased demand for power in space?
So one part of the equation is that as launch costs to space drop, there is more and more demand. It's the basic economic equation of supply and demand. And as launch prices are going to keep falling, there is going to be more and more business models that's going to be available for space. And initially, we just talk about the satellites. And okay, let's say we talk about 10 kilowatts, like what you have on your house. But later stages, there are, and when I say later stages, this could be just a couple of years from now. We'll have AI data centers in orbit. We'll have space-based solar power, which beams down power to Earth to help with our energy needs. And all of these, when you count them as one satellite, it might be a megawatt class satellite. It's 100 times bigger than what you
Mm,
have on top of your roof. And people are also talking about hundreds of megawatts to gigawatts. So,
wow.
and when you count them as like, okay, it's one satellite, well, this is a slightly bit more than one satellite.
And what's the like? I've got this. Obviously, solar panels are a little bit of a commodity these days. Obviously, there's still a lot of innovation and evolution there. But what's the big difference between solar in space and solar on Earth?
So the big difference is utilization. So what you have in Sydney, you are generating about 1.5 kilowatts hour per year of 1 watt of solar panel. So we call this watt peak. So 1 watt of watt peak will generate 1.5 kilowatt hours in Sydney per year. You go to low Earth orbit, this number goes to 4 immediately. The same solar cell, the same solar panel will generate more. And the moment you get into higher orbits, geostationary orbit, which is sort of this 3 Earths diameter away from us, you'll have much larger um, percent when you are in the sun, and so you can generate from the same solar cell 10 kilowatt hours per year. So basically, 6 to 7 times more power out of the same solar cell. Ultimately, your utilization goes up because on Earth you'll have problems around, oh, the morning, the sun is very low in the horizon, the atmosphere is in the way. There is no atmosphere in space. And once you have this, it generates more. Yes,
Yep.
you have a bit more power, but ultimately the utilization rate is what
Wow.
matters. And then in geostationary orbit, there are only very few interruptions to the sun, which
Mm,
means that solar panels work as a base load. You do not
wow.
need the same amount of the huge amount of batteries that we are planning to put next to solar.
Mm.
because it's already you already utilize the solar. You need a tiny amount of battery compared to
Yeah.
what you need on Earth.
Yeah. Wow. That's amazing. It's so interesting. Like I remember it's been 9 years now that I've been working really in sustainability, clean tech, and climate tech, and just every week just learning about whole new categories of things which are incredibly complex and different to the other parts of it, which is really interesting. I mean, tell me about your progress. I understand you've had four launches and one recently. Can you tell us about that?
Yes, we've recently launched 10 solar panels on Skycraft. So you see the Skycraft solar panels here.
Yeah.
And just for the size reference, we are talking about solar panels that are this size that
So
you.
that's one of them, and you had 10 of those.
Yes, we have 10 of those. So what you see here is
Yeah.
one panel, and
Yeah.
then you see the five satellites here
Yeah.
coming down, and each satellite has two panels. And we
Oh, wow.
recently announced this launch as part of the International Astronautical Congress, which was last week in Sydney.
In Sydney, that's right. Exactly. So right up in the sky there now, you've got some panels up there and that's growing. And there's a lot of interest in this, right? There's a lot of companies that need this sort of technology. You know, what kind of companies are the ones you're talking to that are have high demand for a product like yours?
Ultimately, we have something on the order of 40 customers in the pipeline and working with multiple of them in parallel for providing power to their satellites. We've signed letters of intent to purchase with many of them. I'm not going to say the number, how big the number that we've got from some of them. They
Yeah.
will need an insane amount of power in space.
Yeah.
Sort of the long-term average on Earth is 4% growth in the amount of electricity generated.
Yeah.
Um, this, we think, in space is going to be eclipsed by a significant margin.
Yeah, I bet.
We are talking about somewhere in the range to, I don't even know, 50% to 2, 3 times every year. This is
Yeah.
going to keep increasing for the foreseeable future. I don't think anyone has ever said, "Oh, I'll be fine with half the amount of power."
Yeah.
Ultimately, for all of these current use cases, the more power, the better.
Yeah.
Say, for example, on a communications satellite, everything where you generate power, it's all about the the radio power that you emit, and
Got it.
to into all of that, the amount of energy that you can generate is the limiting factor.
That's great. Wow, that's a ton of growth there. That's really, really exciting. I know as well you recently closed a bit of capital and brought on a couple of really good investors who've been wonderful and supportive. Can you tell us just a brief bit about that? It's great to be fueling your growth.
Yeah, so we've raised 900K Aussie recently. We've signed on Flying Fox Ventures and Kylie Fraser. We've got Melt Ventures with Trent Bagnall, and we've got Terry Van Haren as an angel investor. So in the space land, Terry is well known for being the head of Leo Labs Asia Pacific for the last couple of years. And then also he's a retired Air Commodore and have been flying the FA-18 fighter jet for about 30 years.
Wow, that is a great combination. To have him and someone like Kylie, who I think is just one of the most positively active and supportive investors in the Australian landscape in terms of just general technology, and then to have Trent from the Melt Ventures, who are absolutely focused on deep technology, which you are a perfect fit for. That's a really great baseline, and with all that customer interest. I'm sure you've got a plenty of growth coming up next year. So, Peter, thank you so much for sharing with us today. We look forward to hearing more about extraterrestrial power and how it keeps growing. And fantastic work so far.
Thanks, Mick.